So, what is the Pythagoras theorem? And what are the principles behind the Pythagoras theorem? So, by the way, a Pythagoras theorem, it is the theorem that was discovered by a Pythagoras in some years ago. And as the name itself suggests, it is the theorem that was being given. The name of the theorem was given in the honor of this scientist known as the Pythagoras. So basically, a Pythagoras theorem expresses how the sides of the Lagrange triangle are related. So Pythagoras theorem deals with the relationship that exists among the three sides of the Lagrange triangle. So now, what is the Lagrange triangle? So Lagrange triangle, it is the triangle whose one of its internal angles is 90 degrees. Now, this is a typical Lagrange triangle where we have this as the 90 degrees. According to the principles behind the Lagrange triangle, this is said to be hypotenuse, and this is said to be the base, and this is said to be the height. But based on the orientation of the triangle, the base may be given as the height, and the height may be given as the base. It is based on the orientation of the Lagrange triangle. It is based on the orientation of the triangle. Let's say if the triangle stands like this, it means this one will be the height, this one will be the base. Let's say, whatever the case part, the base and the height might change based on the orientation of the triangle, but always hypotenuse remains the same. So, what is the Pythagoras theorem? Now, let's say this is a side A, and let's say this is the side B, and let's say this is the side C, which is the hypotenuse. So now, according to the Pythagoras theorem, how are these three sides are related? So now, the relationship that exists among these three sides, it is in the sense that height square plus the base square, it is the same as the hypotenuse square. And this is true and for the Lagrange triangles. So that's what you call Pythagoras theorem. And let's say the triangle has been given as this. Let's say this is a triangle, and let's say it is given as the triangle A, B, C. According to the Pythagoras theorem, we'll have AB square and plus BC square and is equal to AC square. This is according to the Pythagoras theorem. Now, let's say we have a Lagrange triangle. Let's say it is the triangle A, B, let's say C. In this case, let's say this is the 5 meters, and let's say this is 4 meters. What is the value of the side AC, actually CB, if this is the case? So now we're going to use the Pythagoras theorem. In this case, it is stated that AC square and plus AB square will be equal to CB square. That is according to the Pythagoras theorem. What is the AC? We have it as 4 meters. So have 4 meters square, and plus what is the AB? We'll have it as, should be 5 meters, and which is equal to CB square, and of which this is the same as 16 meters square and plus 25 meters square, and which is equal to CB square. Now for this case, we'll have to add those. What is 16 plus 25? So 16 plus 25, we'll have it as a 41. So have 41 meters square, which is equal to CB square. So now in this case, this is the same as CB square is equal to 41 meter square. So now in order to solve for CB, we'll have to introduce square root both sides. So we'll have to introduce square root both sides. So in this case, we'll have CB equal to 41 meters. So this is the side up to the CB. So now let's say we have this problem. And we have, let's say, a Lagrange triangle that goes like this. Let's say we have it as and we have this is x, and let's say this is 9 and this is 8. So now what is the value of the side x? Now principle remains the same. You should have to understand that this is hypotenuse. According to the Pythagoras theorem, what we have is that we'll have 8 square plus x square is equal to 9 square, according to the principle of the Pythagoras theorem. Now it is unfortunate that the triangle has not been labeled, but if you wish you can label it. Let's say this is a triangle A, B, C, where the Pythagoras theorem can be applied in the sense that we can have it as this. We can have it as AB square and a plus, let's say, B square, BC square, which is the same as AC square. Can be the same as that, which is equal to 8 square plus x square, and is equal to 9 square. So now what is 8 to the power 2? We have it as 64, and plus x square, which is equal to 81, because 9 to the power 2 it is the same as 81. We have x square, which is equal to 81 minus 64. That is upon having the like terms to the other side. Okay, upon having the like terms together. So we have 81 minus 64. So what is 81 minus 64? We have it as a 17. So we have x square. So it should be x square is equal to 17. Of which you have to introduce a square both sides. We'll have x is equal. Now what is the square root of 17? So now the square root of 17, we'll have it as a 4 point. Should be 1, 2, 3. That is to 3 decimal places. So take note of that. And let's say we have this other case as well, and appreciate how we can be able to make that an up to. Let's say we have a triangle that goes like this. So no matter how the triangle has been oriented, but you should know what is hypotenuse and what are the other two sides. Let's say this is 6. What is the value of the side M? In this case, according to the Pythagoras theorem, we'll have it as 5 to the power 2 plus 6 to the power 2, which is equal to m square. This is 25 plus 36, and is equal to m square. And of which this is the same as, now should be 61 is equal to m square. Now that is the same as m square is equal to 61. We'll have to introduce square root both sides. We'll have m is equal to the square root of 61. With your calculator, can you have the solution to the 2 decimal places? So have that on. Now let's think of having, let's say, this case. Let's say we have this triangle, and assuming that Let's say this is 8. Let's say this is x. And let's say this is x minus 2. Now, we can be able to apply Pythagoras theorem in this case of the question. So using the Pythagoras theorem, how can we be able to have the value of the side x and in that case? So now for this case, using the Pythagoras theorem, principle remains the same. We'll have 8 squared plus x minus 2 to the power 2 is equal to x squared. I have 64 and the plus x minus 2 and the times x minus 2, which is equal to x squared. So you should know how to expand the expressions. We'll have 64 plus, now x times x will have it as x squared, and x times 2 will have negative 2x. You also have negative 2x and plus 4, having x times x, x times negative 2, negative 2 times x, and negative 2 times negative 2. We'll have it as that. And that should be plus 4, that which is equal to x squared. So now having the like terms, we'll have 64 and plus 4, that will be given as 68. And plus x squared minus 4x. These are the like terms. And which is equal to, now have it as x squared. And to bring this to the other side, that will be given as x squared minus x squared minus 4x and plus, now should be 68 is equal to 0. This is 0, we'll have it as negative 4x plus 68 is equal to 0. Then we'll bring this to the other side, that will be given as negative 4x is equal to negative 68. Now what is the x? We'll have it as 68 divided by 4, because the negatives has cancelled. So what is 68 divided by 4? Now 68 divided by 4, we'll have it as 17. So the value of x is equal to 17. So you should know that. Now if the value of x is equal to 17, what is the value of the hypotenuse? So we'll have it as 17. And what is the value of that side? So which means we'll have it as 17 minus 2, which is equal to 15. So which means the triangle is like this. We have 8, 17, and this is 15. That is according to the Pythagoras theorem. And for instance, the question also can be given as this. Let's say we can have, this is triangle A, B, C. Now the question could be, find the value of the sides AB as well as the AC. So which means the value of AB is equal to 15 and actually BC is equal to 17 upon having calculated the values of x, rather the value of x in that way. So that's how the Pythagoras theorem can be applied in such case. Let's say this is another case. Let's say we have a triangle, along the triangle that is given us. Let's say this is x, this is x plus 8, and let's say this is the 12. Let's say this is the triangle ABC. Find the value of the sides BC as well as the AC using the Pythagoras theorem. So try to have the solution of that one on your own. I just need the responses in the comment section below. That is, if you may wish to. Let's say we have this other case. Let's say this is the case. Now, assuming that this is 4 this is 2, this is x, this is 8. And let's say that is the case. So find the value of x using the Pythagoras theorem. Now you should know that we have, let's say this is the triangle A, B, and let's say this is the D. So now we are having two right-angled triangles in this case. We have the triangle which is the triangle ABD, and we have the triangle ABC, as you can see. So those are the typical right-angled triangles that we are having in this diagram. So how should you have the value of the side x? So now, in order to have the value of the side x, we are going to use the Pythagoras theorem. Now, the side x, it is the hypotenuse of the triangle ABG. So all we need is the value of the side AB. How should we have the side of the how should we have the side AB? We are going to use the bigger triangle. So let me present the big triangle. Now the bigger triangle, it is given as this, where we have AC and we have B here. So what is the AC? We have it as 6. That is the combination of the two. And we have here as 8. So we're going to have the value of the side AB in that case. So now in this case we have it as AB square and plus AC square, which is equal to BC square. So now what is AB? It is what we are looking for. AB plus what is the AC? We have 6 to the power 2, which is equal to 8 to the power 2. We have AB square and plus 36, which is equal to 64. Now we have AB square, which is equal to 64 minus 36. Now what is 64 minus 36? So now 64 minus 36, now we have it as 28. So which means AB square is equal to 28. Now we have to introduce the square both sides. We'll have it as AB, and that will be given as the square root of 28. Of course, we can have it in a decimal form. So what is the square root of? We have it as 5.29. That is to 2 decimal places. That is the value of the side AB in that case. So now that we have AB, we can be able to have now the value of the side x using the small triangle. Now let me have the value. Let me have to present the small triangle. So now this is 5.29. So now actually we're going to have the value of x using the small triangle. And let me present it properly. You should have to see in a light way. So this is the small triangle that we are having, which is a B, A, and this is the D. We have this as 4. We are looking for x, and this is should be 5.9. 5 should be 29. Now using the Pythagoras theorem, you'll be able to have the value of the side x in that case. So that's the principle behind Pythagoras theorem. And let's say this is the case. What if we have this triangle as well? Let's say we have the system of the triangles. That is, let's say this is 7, let's say this is 7 and this is the x, this is 3, and also let's say this is 3. Now how should we have the value of x? So now we have two triangles here. We have two right-angled triangles. In this case, we have the bigger triangle, which is ABC, and the smaller triangle, which is ABG. So the value of x we're told to have, it is the hypotenuse of the bigger triangle. So which means we are going to use the Pythagoras theorem, and for the triangle now should be for the bigger triangle, where this is x and we have this is 6 upon having this plus this. Now we have A, C, B. All we need is the value of the side AB. That we're going to have it using the smart triangle. And what is that smart triangle? We have it as that, where this is 3, this is 7, A, B, actually D. So we'll have the value of AB here, and that will be substituted here. Then we'll be able to solve for x in that case. So that's how the Pythagoras theorem can be applied in that way. So now let's say we have this kind of the weight problem. Find the length of a diagonal of a rectangle of length 9 centimeter and width, it should be width 4 centimeter. So here should be width 4 centimeter. So now how should we have that? So now first thing is that you should know what is a rectangle and how the rectangle looks like. So now this is a typical rectangle we are talking about. The next, you should know that the rectangle consists with length as well as the width. And for this case, this is the length, because we are being told that the length is given as 9 centimeter and the width has been given as 4 centimeter. The next, you should know that the opposite sides of the opposite sides of the rectangle. You should know that the opposite sides of the rectangle are the same. It means this is 9 centimeter. This is also 4 centimeter. Then what else should you know about the rectangle? So on a rectangle, if we are saying a diagonal line, it is the line that connects the two opposite angles or opposite corners of a rectangle. For this case, this is a diagonal. Of course, we can also have it as this. This is also a diagonal. So for the interest of accurateness, and also for the interest of how best should it be, we'll just have to present that single diagonal. So we are looking for this diagonal, the length of this diagonal. And now you can see that what we have is right-angled triangle, where this is the hypotenuse, and we have this side as well as this is actually that side. Using the Pythagoras theorem, the length of the diagonal can also be calculated in the same way. So try to have the length of the diagonal, in that case using the Pythagoras theorem. So now let's say this is the question. A square has a diagonal of length 10 centimeter. Find the size of the square. So in this case, what is that you should know what is a square. If we are saying a square, it is a four-sided figure with the similar sides. That's what you call a square. So in this case, this is a typical square. And we should know that a diagonal, it is the line that is connecting the two opposite actually corners. So that is the diagonal. And we are told that the diagonal is 10 centimeter. So the diagonal is 10 centimeter. Then we should find the values of the two sides of the triangle. Should be the two sides we should find the values of the sides of the square. Now we should know that we have this side which is the same as this side, this side which is the same as this. In other words, all the sides are the same. So now how should we have that on using the Pythagoras theorem? So now you can see that what we have here is the ladder of the triangle, in the sense that we're going to use the Pythagoras theorem. Now you may pretend to be scared to say, how should you use the Pythagoras theorem? From the fact that we only being given the one side and we do not have the value of the other side, so that we can be able to have the value of the other side. So the essence behind is this: from the fact that the two sides are the same, then here will be the way out. Side square plus side square is equal to 10 actually a square, according to the Pythagoras theorem. But now these are the same, hence they are like terms. We'll have it as 2 side square, which is equal to, we'll have it as 100 now. So half of side square is equal to 100 divided by 2. Therefore half of side square is equal to, now should be 50. So now for this case we'll have to introduce both sides as square root. We'll have a side that will be given us the square root of 50. So that is the value of the sides of the square in that case. Of course you may think of expressing that one as a decimal number, but just have to put it in that way. But with your calculator you can have the answer in a decimal actually form. So that's how the Pythagoras theorem can be well understood. So don't forget to subscribe to my YouTube channel, because I always make these videos and that should not have to miss. So for you to receive the notification for every video that I've produced, then you just have to subscribe to the channel, then you'll be notified at whichever the time the new video has been uploaded. Thank you.